Yeah, the topic is chaining. In the previous video, we have seen modulus hash function and the drawback of modulus hash function. That is, more than one keys will map on the same location and it causes collision. So let us see how to avoid collision or how to resolve collision. So for resolving collision, chaining is one of the method and it is also comes under open hashing. So let us learn about this topic. So in this topic, I will be showing you how to perform following operations, like how to insert and how to search and the analysis of search. Then also we will see how to delete. So these are the operations we will learn on chaining. So let us start. I already have a set of keys kept here, and those set of keys I have taken in a key space, and the hash table size is 10. So hash function is h of x is x mod size is 10. So I will directly write 10 here. That is the size. Now using this hash function, I will insert these keys in the hash table. So let us do it one by one. 16 mod 10 is a 6. So it is inserted at this place. Now as this is chaining, so it is not directly inserted at this place, but here a node is created, that is a linked list, and there the value is inserted. Yes. So it means this is a pointer to a linked list. Yes, this is a head pointer to a linked list. So this is a array of pointers to linked list. Yes, it is implemented using array of pointers. Then let us insert rest of them. 12 mod 10 is 2, so it is inserted at this place in a node. 25 is 5. 39, 6. This is a collision. But here we are inserting in a linked list. So I will create a new node and insert here. But 6 is smaller than 16, so 16 should go there and 6 should be inserted here. Means these keys must be inserted in the sorted order. They must be kept in sorted order so that while searching it is easy for search. 122 is greater than 12, so it's inserted there. The next is 5. 5 is mapped here. So 5 is smaller than 25. So 25, 5 comes as a node before 25. Before 25. 68, it's inserted here. 75 again mapped at 5. So 75 is greater than 5, greater than 25. So it should come here as a last node. So that's all. I have inserted all these keys and the keys are inserted in chains. So yes, these are array of chains. So hash table is made out of array of linked lists or array of chains. See, the hash table size is 10. So beyond this, we are taking more extra space. So this linked list can go to up to any size. So you can insert as many keys as you want. There is no limit for the size here. Now we have seen insertion. Insertion was very easy. Then next, let us see how to search. I want to search for a key 12. Use hash function. 12 mod 10 is 2. Go to index 2 and search in this linked list, in this chain. So yes, 12 is found in just one comparison. Successful. Search is successful. I want to search for a key 75. Take this hash function. Hash function will give the index of 5. Go to index 5 and search for 75 in this chain, in this linked list. Is it 75? No. Is it 75? No. Is it 75? Yes. Found. So search is successful. Now search for a key 65. Take this hash function. 65 mod 10 is 5. Go to index 5. Search for it. 5. No, 65 is greater. 25. No, 65 is greater. 75. No, 65 is smaller. So key is not found. Key is not found. So search is unsuccessful. For these two keys it was successful. Now let him take one more key. 15. 15 mod 10. 5. Search here. Is it 15? No. 15 is greater. Is it 15? No. 15 is smaller. Stop. Don't check further. If they are sorted, that is the benefit. You can stop if the key is not found and if you got an element greater than the key that you are searching. So for 15 also search is unsuccessful. That's all. Insertion is also easy and searching is also easy. Now let us do analysis and find out how much time it is taking for searching in case of successful search as well as unsuccessful search. Now let us do analysis. I have the number of keys that are n. Suppose I have 100 keys. Here I have few keys, only 9 keys are there, but assume there are 100 keys, right? And the size of the hash table is 10 because the hash function is x mod 10. So the hash table size is 10. So in this chaining, though the size of the table is 10 only, but there is no upper limit. You can add as many keys as you want because they are getting inserted in chain. So I am taking size number of keys as 100. Now the very important thing, I'll take n by size, that is number of keys by size. This is represented with a lambda or alpha and it is called as loading factor. This loading factor is very important in hashing. So we find out loading factor. Loading factor is number of keys divided by size of the table. Now remember one thing. All the data structures that we have analyzed so far, we were analyzing them based on a number of elements, n. But here it is not based on number of elements, that is not based on keys, n. But it is based on loading factor. So analysis of hashing is always done based on loading factor. Remember this one. So as per our example, if I say I have 100 keys and the size is 10, hash table size is 10 means 100 by 10 is 10. So the loading factor is 10. So what does it mean? It means that at each location there are 10 keys. There are 10 locations. At each location there are 10 keys. Because this is a chaining, we got the loading factor greater than 1. We got the value 10. So with this 10, we are assuming that the 100 keys that I have are uniformly distributed at each location. So each location is having around 10 keys. We are assuming this. Our assumption may be wrong, but we are assuming this, or actually we are expecting this. We are expecting that every location is having 10 elements. If I have 100 elements. So if you observe in this example, what we have seen, one element and two elements. This is having 3 elements and they are not having any elements. These are still empty. These are empty, right? These are nulls still. Anyway, the reality is something else, but we are assuming that the keys are uniformly distributed. Now, based on this, we will do analysis. Now, let us see what is the time taken for searching in case of successful search. Time taken for successful search. So, for successful search, we say time is, first of all, we use hash function for getting the index and that takes constant time, 1. Yes, 1 for computing hash function, which takes constant time. Second one is, we have to search in that particular chain, in that particular linked list. So what could be the average time? Average time will be half of that loading factor. So we are assuming that at each location 10 keys are there. So for searching, maximum how many comparisons? 10 comparison. Minimum how many comparison? Just 1 comparison. Average how many? Half of it. So whatever the lambda is, lambda by 2. So this is the time taken in case of successful search, and this is average time. This is average time, right? Average successful search time. 1 plus lambda by 2. 1 is for hash function, lambda is the loading factor, by 2 gives average. Then what is the time in case of unsuccessful search if the key is not found? For average unsuccessful search time, for searching any key we use hash function. So for hash function time is 1. 1 plus key is not found means We may be checking entire linked list, entire chain. We don't know where it may stop. So we say that maximum time it takes. So that how many keys are there? 10 keys are there. That's what lambda. So it is 1 plus lambda. So we are taking maximum time here, the maximum possible time. We don't know when it will stop, right? So it means we assume that it will stop at the end. So the key is not found. So it is lambda, 1 plus lambda. So for searching, successful search, this is the time taken, and unsuccessful search, this is the time taken. So I have discussed searching, analysis also. Now the last thing is delete. Let us see how to delete any key. Suppose I want to delete a key 12. This key I want to delete. So for deleting 12, use hash function. It gives index 2, go to index 2, search in this chain. If it is found, delete a node. Simply it is just like deleting a node from linked list. So deleting a node. If it is found, delete it. So the procedure is simple. So for insert, search and delete, for all of them, procedure is simple. Insertion time you insert in a linked list, search time you search for it, search in a linked list, and deletion time you delete a node from a linked list. So the operations are same as linked list. So that's all about the operations in case of chaining. Now few important things in this one. See, the hash function need not be x mod 10. We are doing it based on last digit. Last digit. That is, we are looking at last digit. If you say, no, I want to look at second digit, okay, you can look at second digit also from right side, right? Second last digit. So you can write a hash function for that one also. Hash function will be h of x is equals to x divided by 10, then mod 10. If you want, you can modify the hash function. It's not necessary that you take mod means last digit only. The benefit of mod is the size of the table will be limited. So if you say mod 10, you need the size from 0 to 9 only. That is 10. If you say mod 20, then the size of the table can be from 0 to 19. So you can limit the size of a hash table. That's why we use mod. But for generating the indices, you don't have to take always last digit only. You can take any digit. Now I will show you one problem. And from that problem, after that problem, we will also see a solution. Just watch here. See, suppose I have the keys like 5, 35, 95, 145, 175, 265, 845, 55, 25. All the keys are ending with 5 only. If I use this hash function, this mod 10, then all the keys will be mapped at same index 5 and the chain of all the keys will be formed here only and all will be empty. Yes. So the idea that loading factor means the keys are uniformly distributed, that fails. That fails. That assumption fails. So then who is responsible? Hash function. Hash function. Hash function, is it a standard one that you must take this only? No, you can take any hash function. Then who is responsible? The person or a programmer who has selected the hash function. So you select the hash function such that the keys are uniformly distributed. Yes. So we assume that you have selected a proper hash function which is uniformly distributing the keys. That's why we do the analysis based on lambda. If you're not selecting a proper hash function, you don't know hashing. Simply. Don't blame hashing technique. You don't know how to use hashing. That is the meaning. Then how to decide hash function? You must have idea about the keys that you are going to insert. Yes, you must have the idea. What keys you are inserting? What is your data you should know? Then only you will find a solution, right? Without knowing data, you cannot find a solution. So you can select a hash function such that at least to a major extent, the keys are uniformly distributed. So we are assuming that approximate distribution, right? So it's not accurate uniform distribution. Approximately 10 keys are there at each location. More or less, not a problem. So that's all about chaining as a resolution method or resolution technique in hashing. Now we have other methods also. We'll look at them in next videos.